Computer numerical control, or CNC machining, is incredibly satisfying to watch. How exactly is the machine able to cut such intricate geometric patterns? If you want to produce this stylish impeller or this sleek chess piece, all you have to do is feed the CNC machine a code called G code and M code. Later, we'll go over what G and M stand for. Let's see what happens when you feed this code to a CNC machine. The movement the tool is doing is beautiful, but it's slightly difficult to understand. The machine you're seeing here is a slightly complicated machine called a 5-axis CNC machine. Before diving further into how it works, let's first explore some more basic machines. Suppose you want to engrave this logo on a steel plate. At a glance, it seems that the tool motion needed to make this engraving is simple, requiring only 2 dimensions. Just by moving the tool in X and Y directions, we can perfectly achieve this engraving. Such CNC machines are known as 2-axis machines. Now, let's review some basic information about G and M codes. First off, G stands for geometry. This means all the information required to achieve the shape of the object is conveyed by the G code. M, on the other hand, stands for machine. This means all the machine-related information such as coolant control, tool change, and spindle speed are controlled by M code. Now comes the next machining challenge: how to machine this piece. Here, the depth of the machining varies, meaning that you must control the tool in the Z direction as well. You'll notice that when the tool moves in the Z direction, the X and Y movements are absent. This technique works for simple geometry. Such simplified machines with Z direction movement are known as 2.5D CNC machines. What about this shape where the depth varies gradually? This requires the tool to move in the Z direction along with X and Y movements. This is an example of 3D machining. Now, what about the blade of a steam turbine? The only way to produce such a shape is by spinning the part in the Z direction along with the tool movement in X, Y, and Z directions. This is known as 4D machining, as shown in these visuals. If you have CAD models with you, just by placing an order on the JLCPCB website, you'll be able to convert the CAD models to reality. Look at this example to understand how easily you can upload your CAD file and select the material you want, and other parameters. They have worldwide shipping, and within a few working days, you'll receive the final product. As you can imagine, the CNC coding required for such a complicated shape is also complex. However, thanks to modern CAD/CAM software, this is easily achieved. Just feed the CAD shape of the blade and other machine parameters to the software, and the G and M code will automatically be generated. What's even neater is that the software can even simulate the tool path. However, if you want more accurate control over machining, you can still write this code manually. Now all you have to do is feed this code to your machine. Any machining operation generates heat. Without addressing this, the heat can easily deform the material and affect machining accuracy. The CNC machine uses a coolant arrangement which can be controlled through M code. This real footage provided by JLCPCB shows the details of the cooling of the tool and workpiece. Let's return to the impeller we saw at the beginning of the video. It's impossible to create this shape even with a sophisticated 4D machine. To achieve this curvy shape, there must be one more rotational motion. This means that the machine must be modified again. You can clearly see that in this machine, this extra axis of rotation is given to the tool. As you may be able to guess, this is called a 5D machine. If you have a complicated design but can't afford such a sophisticated machine, just contact JLCPCB, the technical support and sponsor of this video. If you send them a CAD model, they'll send you back the finished machined part in 3 working days. To better understand how the 5D operates, have a look at this chess piece machining CNC machine. You can even observe the automatic tool changing capability of the CNC machines in this machining process. After the final finish passes, the knight looks so elegant. Note that many variations of the 5D machines are available. For example, have a look at this tiny 5D CNC machine. Here, the 5th rotation angle is assigned to the workpiece. We would like to thank the technical support provided by JLCPCB in the production of this video. Their CNC machining capabilities are truly a treat for the eyes. To learn more about the CNC services offered by JLCPCB, please visit their website. Thank you for watching the video.